Hello viewers, today we would be starting with part 5 of the video of electricity chapter. This video is useful for only ICSE students of class 10 because this part is not there in CBSE. What is an EMF? EMF is basically the kind of a voltage which is this. For example, if you see this particular battery, you can easily read it is written 9 volt. It means this particular battery is going to provide me 9 volt when I connect it to a circuit, right? But in reality it is never the value which is written here, right? Okay, now starting with this, here in this particular case we have got two terminals. One is this positive written and one is negative, and this battery consists of chemicals which are stored here, which are going to react and they are going to produce electricity when we connect it to a circuit. Circuit means with the help of wires, and we want to make it in a working condition. Now if suppose example, if it is written 9 volt, what do you mean by 9 volt? It means it is going to, this particular battery is going to transfer 9 joule energy to each and every charge which will be passing through these two terminals, right? So why? Because we know V formula is work done by charge. So work done to move a particular charge from one point to another. So from here EMF would be, here it is going to offer the charge work to move from this particular point to this particular point, right? Now terminal voltage. So when you connect this particular battery to a circuit, I'm just giving you an example because this battery is not in a working condition. I am just going to explain you what do you mean by terminal voltage. So if you connect this particular, say, LED with this, oh, it's broken already. I'm just giving you an example. So just imagine this to be a bulb. It's actually a resistor, not a bulb, right? So if you're going to connect this thing with, say our battery like this, so you will find out that the value which is written here, which is 9 volt, the value will come out to be always lesser than 9 volt. How can you check the value is either 9 volt or it is less than 9 volt? With the help of voltmeter. You are going to connect your circuit to the voltmeter and you will find out the value is always lesser than what is written. Why now? Because actually in the external circuit, like I've drawn this here, if this is the electrode, positive and negative, this is the terminals and this is the wire that is connecting it, right? So in external cell the electricity is produced by movement of electrons, but when you talk of a battery, inside this we have got chemicals, cation and anion. When these cation and anion, they move in an electrolyte. Electrolyte is something which dissociate into ions when when you take it in a, like if you pass electricity through it or something like that, right? So when this charges, they move from one electrode, they are attracted to one particular electrode, like positive would be attracted to say negative and negative would be attracted to positive. So when they move, because of the electrolyte, their speed reduces, and when their speed reduces, they take more time to reach the particular electrode. I'll give you one analogy to understand this. Suppose if you swim in a swimming pool, so you can imagine yourself to be an ion and that swimming pool can be the electrolyte. So when you swim, what it will become? It will be very difficult for you to swim easily in swimming pool, right? And similarly happens with the electrolyte. When electrolytes, when the charge move in electrolyte, so electrolyte is going to slow down the movement of the ion. So that is said to be the resistance that this particular cell is going to offer, because of which the value of voltage, it decreases, right? So terminal voltage is the actual voltage at which a cell is going to work. So if it is written 9 volt, maybe it will be working at 7 volt or 6 volt. So that is said to be terminal voltage when you connect this particular thing to the circuit, then only. Now next topic is voltage drop. Voltage drop is that voltage that won't be available to us because of the internal resistance, right? Now for example, if you have got this 9 volt battery, so if I say the actual voltage that at which this particular battery works is 7 volt only, so where is that 2 volt? So 2 volt is the voltage drop, that is reduce in the voltage because of the resistance. Not total EMF. EMF is given by symbol epsilon, right? So that is given by terminal voltage plus the voltage drop, sum of these. Next is the internal resistance. I already told you beforehand only that it is because of this particular cell, because of the chemicals which are present inside, the electrolyte doesn't allow ions to reach easily to these particular electrodes, due to which what will happen, the speed of the ions will reduce down and automatically the voltage would reduce. So it is due to the resistance that electrolyte offers in this particular battery. So symbol for this is small r, and total resistance will be given by capital R plus small r. And symbol is, you draw a cell or a battery, whatever, like in this case we have taken a cell along with a resistance shown here, and you have to put a dotted box here. Next is, you have to remember these expressions. Suppose you take this as your circuit. Here is R is the resistance. Suppose the same thing, suppose I connect this thing to my, say, battery or a cell, right? So this particular thing, it's a resistor actually, right? This particular thing would be my resistance, and battery will offer me internal resistance. So you can compare this circuit with this particular circuit. Total resistance would be given by sum of these two resistance. Now in the previous cases we were not taking this resistance, but now we would be taking, if they are saying about internal resistance. I is given by V by R. V now here would be total EMF, that is epsilon upon resistance would be this value. EMF formula will become, this thing will go here, so this will become this formula. After that, terminal voltage according to Ohm's law is V is equal to IR, and voltage drop is due to the internal resistance of this cell, that is written as small r. So when you are going to find the value of R, it will be small v by I. Okay, now you can put the value of small v from this value, from this equation here, upon I. Now I could be written as V by R, and you get this expression. How? See, this expression is this only, right? R will go on the top, you divide V twice with this also, with this also. So you will write it separately, this will get cancelled out, you are left with 1, E by V minus 1 R. So I hope you have understood the difference between EMF, terminal voltage, voltage drop and internal resistance. I am going to repeat again. EMF is the voltage which is written here on this particular battery or a cell when it is not in a working condition. Working condition means you have not connected it to any kind of circuit. Terminal voltage is the voltage that this cell is going to work at in real when you connect it to a circuit, right? So if 9 is written here, so if it is working at 7 volts, so 7 volt would be the terminal voltage, and 9 written here is the EMF. And voltage drop is because of the resistance, internal resistance, which the chemicals offer to the movement of ions, which reduce the value of the voltage that is written on this cell. So who is the culprit here? The electrolyte is a culprit here, which is actually reducing the value of the voltage which is written on this particular battery, right?